In this video, I'm going to cover practices 7 and 8. So let's look at practice 7 first. Practice 7 is engaging an argument from evidence. So let's look at that word argument in a scientific term. A scientific argument is not a disagreement, but more of an explanation and reasoning to back up evidence. Practice 7 allows scientists to evaluate their work and the work of other scientists. There are two different types of arguments, informal and formal. Let's look at informal argument first. An informal argument is when scientists are able to discuss their findings or ideas and compare them to one another through their evidence. So an informal argument, for example, students may examine scientific information and share their ideas and interpretations with other classmates. Let's look at formal argument. A formal argument is when scientists gather all of their evidence and information from their findings and has it reviewed and published. When scientific evidence is published, other scientists often review it and argue with whether they can prove it right or wrong. In order to prove evidence, scientists need to argue the reasoning that they have found. Now let's discuss how that would look in a classroom from kindergarten through 8th grade. In kindergarten through 2nd grade, students will be engaging in arguments from evidence in building on foundational knowledge in order to understand the beginning of the scientific process. When I was student teaching in 2nd grade, I taught an experiment called the mystery box. I put a mystery object in a box, and each day the students would get a clue of what is inside. The students then had to use evidence to create their own idea of what was in the box. Here is an example of some of the questions that they were asked. So I would go around to the classroom with the box, and I would shake it, and they would have to figure out what it sounded like. The next few days, I would then have them smell what's inside the box and feel what's inside the box without looking at it. So the students then had to use evidence to create their own idea of what was in the box. They then constructed an argument as to why they picked that object. This allowed students to find evidence and use their prior knowledge to create an argument for that evidence. In grades 3rd through 5th grade, students build off of their knowledge from kindergarten through 2nd grade. Students start to create their own arguments and share their ideas and findings with their peers. They begin to learn how to critique others' findings and receive feedback on what they have found. In my 4th grade class, we look at data through graphs and models to understand the arguments being addressed. Here's an example of a model and graph of what they would use in 3rd through 5th grade. In these grade levels, students begin to understand visual representations of their evidence and the findings from others. In 6th through 8th grade, students build off their knowledge by taking evidence and constructing an argument to provide an explanation. Students learn how to argue their side by proving or disproving evidence. Students might begin creating formal arguments in which they publish their evidence to other scientists or their peers for critiquing. Now let's look at practice 8. So practice 8 is obtaining, evaluating, and communicating information. So communication in science is extremely important in order for scientists to share their explanations and findings. There are two types of communication, formal and informal. Let's start with informal communication. Let's start with formal communication. So formal communication is when scientists present or publish their findings in order for other scientists to review and critique them. Informal communication is when scientists have discussions with other scientists in order to share their information or gain information from others. The first step in obtaining information is understanding and interpreting the information given to you. Scientific texts can be extremely difficult to interpret at times, so it is important to be able to understand the information that is given to you before critiquing it. Once scientists are able to create an understanding of the information, they can then communicate it and present it. Now let's see how to do how practice 8 works in K through 8th grade. In kindergarten through 2nd grade, students may be given grade-appropriate texts in which they are asked to dissect and understand main arguments. Once students are able to obtain and comprehend scientific text, instead of just handing out scientific articles for students to read independently, kindergarten through 2nd graders, teachers must explicitly teach them strategies on how to find and understand important information through the text. This can be done through group readings or entire class readings, so students are able to communicate their understanding better. In grades kindergarten through 2nd grade, scientific information will be in the form of mostly pictures, graphs, models, and examples. In grades 3rd through 5th, students may be given grade-appropriate texts in which they are asked to dissect and understand main arguments. Once students are able to obtain and comprehend scientific texts given to them, they are able to design solutions to the problem at hand. This may be in the form of charts, models, writings, or oral presentations. In grades 6 through 8, students build off prior knowledge from grades kindergarten through 5th grade. They are given grade-level scientific tests and asked to comprehend information in their own way. This can be done by using multiple resources in order to compare and contrast evidence to create their own ideas. This is an example of what that may look like. This can be done by students begin to understand the biases that come from various sources in order to create their own argument about the topic. Once students understand the scientific information given to them, they're able to construct an argument to support the evidence of their findings. This can be done through writing or oral presentations. On this example, you can see that some of the charts are being compared to one another. Students in these grade levels are able to understand, comprehend, and compare other data with other scientists. And that is practices 7 and 8.